Okay, in the previous video, we looked at perfect squares, we looked at difference of squares, and now we're going to look at sums and differences of cubes. Now, this is different from, we saw how, say, x plus 1 cubed can be FOILed as x cubed plus 3x squared plus 3x plus 1. That was, in fact, one of your bonus questions, right? But this is a different case. It's when you have a cube plus b cubed, which is different. So not that a plus b cubed is not equal to a cubed plus b cubed, which is immediately obvious here, right? You have all these 3x crap going on, so they're not the same. But it turns out a cubed plus b cubed can be factored as a plus b times a squared minus ab plus b squared. So notice the sign here. When it's a plus, this is plus, so that's same. But this sign is opposite. But if it's a minus, again, this sign is the same, but this sign is opposite. So it becomes a positive. And this one is always positive. It's factor x cubed plus 125. X cubed plus 125 can be written as x cubed plus 5 cubed. So I get x plus 5, x squared minus x times 5 plus 5 squared, giving me this expression. Similarly, x to the 6 plus 64y cubed. The trick here is to identify the pattern and see if it fits into the pattern. For example, my first observation is that x to the 6 can be written as x squared whole cube. And I also observed that, well, 4 cubed is 64, so we are in the cube business. And this can be written as 4y whole cubed. And then you apply the formula. Example with negative 1 minus 27. Observe that 3 cubed is 27. So again, you can use the difference of cube formula here. Now in this case, this is a negative and this is a positive. So again, note the signs. Be careful about the signs. So it's the same and opposite and same and opposite. In some cases, your a can be 2x or 3x squared, and you have to be careful about evaluating a squared. For example, over here, this is x squared. So when you're doing x squared squared, make sure that you get x to the 4. Yeah, so be careful with what is this a term, right? It could be linear or it could already have some exponents in it. General factoring strategy. The first thing you want to try to do is take out GCF. For example, you look at an expression and you already know, oh, I can pull out a 2x or I can factor out a 3x. Once you're done that, then you can look at what's left and see if a special form can be applied. Is it sum of cubes? Is it difference of cubes? Is it difference of squares? Is it a perfect square? If not, is it a trinomial? Can you split the middle term? Or if it has 4 or more terms, then you try factoring by grouping. For example, immediately obvious that the 4y is a GCF, factor it out, end up with a trinomial. I split the middle, so this is trinomial, and over here I split the middle term, and I get 4y, x plus 1, and x minus 5. The next is, I got 4 terms, greater than or equal to 4 terms, grouping. But before grouping, we're going to have to rearrange because as I noticed, there is nothing common between the first two and the last two. Plus I noticed there is a 9 common between the first and the last and a 16 between these two. So it makes sense to rearrange the 9s together, the 16s together. And then, because we are factoring completely, 9b squared minus 16, we can apply the difference of squares to factor it a little more. Find the expression for area of the shaded region. This is given to be, so if you have two circles of radius x, the definition of radius is it's going to be same everywhere. So that length is x, and then that length is x, so that the length of this side of the rectangle is 2x. Similarly, that's x, 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 and x, so that this whole length is 4x. So the area of the rectangle is 2x times 4x. Now the circle area is given by pi r squared. So it's 2 times pi x squared, which becomes 16x squared minus 2 pi x squared. And it's immediately clear that I have a GCF of x squared, in fact 2x squared, and I'm left with 4 minus x. So this is just another way of asking you to factor certain equations. That's it for this week.